about is what is invariance mean? Well, to vary means to change. So invariance means not varied or not changed, which means constant. So some transformations have invariance qualities, which means that these transformations keep the image constant. If the pre-image and the image of a given transformation share certain characteristics, then the transformation preserves that characteristic. We're going to go ahead and use this word preserve. Okay, it's preserving the characteristic. So, what type of transformations preserve? Well, reflections, rotations, and translations. They preserve distance because the image is always exactly the same distance from the line of reflection as the pre-image is. So the distance is preserved. So let's talk about a new vocabulary word. We have a word called isometry, and an isometry is just a transformation that preserves distance. So anytime you have a transformation that's going to preserve distance, it's an isometry. So isometries, these include the following transformations. Anytime you do a reflection, it's an isometry, a translation, a rotation, the identity transformation, or anytime you compose different isometries, all of those transformations are considered isometries. They all preserve distance. So there are 6 properties of isometries. The first property is that distance is preserved, right? And in fact, that's part of the definition for isometries. And the next property is that the collinearity of points is preserved. So if 2 points are on the same line of the pre-image, those 2 points will also be on the same line in the image, right? And so our third property is the betweenness of points is preserved, which makes sense since distance is preserved. And the fourth property is that angle measure is preserved. Again, if distance is preserved, it makes sense that angle measure is also preserved. The fifth property is that parallelism is preserved. And the sixth one is that triangle congruence is also preserved. So all of these properties make sense if we define isometries as distance being preserved, right? They kind of follow suit all these other properties. So there's a theorem called the isometry theorem, and it says that every isometry can be expressed as a composition of at most 3 reflections. So if you have an isometry, you can prove that is an isometry by stating what 3 reflections are happening. Okay, at most what 3, because an isometry has to be built by at most 3 reflections. So let's talk about something that does not preserve distance. That would be a dilation, right? In fact, dilation, that's where you have a scale factor and the distance changes. So since dilations don't preserve distance, they are not isometries. A transformation that preserves shape is called a similarity, okay? While a transformation that preserves both size and shape is an isometry. So let's say you have something and the distance is not preserved, right? Distance is not preserved. However, the shape is still preserved. Well, it's not going to be an isometry, but it will be a similarity because the shape was preserved. So let's talk about properties of dilations. The first thing that the dilation preserves is the collinearity of points. Your points will still be on the same line if they are on the same line in your pre-image. Dilation also preserves the betweenness of points and angle measure and parallel lines. So similarities and isometries are not the only types of transformations. You can have transformations with none of these invariant qualities. So there are lots of other transformations out there, but similarities and isometries are just two types of transformations. All right, your turn. You're going to go ahead and try 12.4, 2 through 6 evens. I'm available to check your work and help you out if you need it.